Hey everybody, how's it going? So I've been working on this tricorder a little more. Next step is to somehow get the electronics into the tricorder itself. I have a nice breadboard mess down here on the desk, and it just needs to somehow get to a point where I can fit it inside the tricorder. Unfortunately, I'm looking at like using really tiny little circuits, particularly for the hand scanner. I mean, this thing is like that big, right? And it needs to fit 2 chips in there and then also fit all the lights and stuff. So, and then a bunch of resistors and a couple capacitors. So there's a lot in there. Somehow we're gonna fit it in. How are we gonna do it? Well, let's find out. Keep watching. One thing I have to tell you is that this tricorder, the body, was created by this guy named Myron Stapleton. And fantastic job. He was basing it off of the Roddenberry.com tricorder body, which I had one at one point and it kind of sucked because it was like it took a lot more work to try to get to just this point. So major props to Myron Stapleton for making such a beautiful looking body. Of course, I had to do a bunch of body work to it, and then I did the paint job on it to make it look that good. It took a long time, but we're there. Now it's time to light it up. All right, so thanks, Myron. So here's the blinking lights again. I have to say that the only reason I started doing this is because I paid this guy GM Props like about $300 to send me real finished electronics, and I never heard back from him again, and that was like about 2 years ago. So I'm pretty sure that I'm probably never going to hear from him again. So we make our own electronics, and they're probably going to be more accurate because I'm doing the research. All right, so this is the first version of the daughter board for the medical tricorder. It's going to sit somewhere in there in the top part, and as you can see, it has the 2 chips in there and then all the resistors. This actually doesn't work at all, and I figured out why it doesn't work, and it has to do with the resistors, and actually it has to do with the timing resistor and the capacitor rating. One of the capacitors, 2 capacitors in this thing, one of the ratings is off. So I had to troubleshoot, fix it up. That's why you always want to breadboard your electronics like this, right? Because then you could know it works, and you could know everything works, and you can look at it and you could see all the wires, right? I know it looks kind of messy, but I probably could have breadboarded it better to be even more legible, but trust me, I know what's going on here. Pretty cool, huh? So this is no good. We're gonna have to go back to the drawing board on this, and I'll show you exactly how I created this. This is the chart that shows what the circuit is for the tricorder. Although this one here has looks like 10 different flashers, I'm only going to use 4 of them, and 3. So luckily there's the reset button, which is, you have to know a little bit. So the 4017 chip, you could make it count as far as you want, up to 10. And since there's only 4 lights, and then it goes back to 1, and you just want the 4 lights to sequence, then you have to make it reset on the 5th light, right? The 5th number. So to do that, you just run your master reset, which is pin number 15, to your 5th input. Well, I guess in this case it would be the 4th input, because we have the first one is 0. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you have 10 different slots, and 9 is the highest, 0 is the lowest, and so you want it to reset on number 4, and so you just would run a lead from 15 to 4, which in this case would be pin 7, no, pin 10. sorry, pin 10 is what the reset is. And so that's how that works. And then the 555 timer chip is what gives it its time to switch the sequence. And I feel like I have unlocked a major victory here. Here is the daughter board for the tricorder. This is the front. Don't worry about these red circles. They're going to be okay. It kind of has to be that length. That just means that it's getting too close to the edge, and that might be an issue, but in this case it's not an issue. It's just because I have the tolerances set too low. So that's what's going on. Here's the back of it. See, so I've got all the connections, and this should work pretty good. This is going to be the version 2. So I showed you version 1 over there on the bench. This is going to be version 2, and we're going to order it from JLC PCB, which is always a lot of fun when you get to see that stuff done. Basically what they do is they take this board here, they have a computer that takes all the parts, it selects all of them, the machine, it runs the board through, and then it has a CNC cutter that cuts the board, and then it places all the materials onto it, it solders them. It's pretty cool. It does it all with the computer, and it goes really quickly. And this board actually is going to be like, you know, that big. So, you know, these resistors are like the size of rice grains, you know, like it's pretty amazing what they can do. So that's the daughter board for the top part of the medical tricorder. Oh my gosh, I always learn these lessons time and time again. This is really not that funny. I ordered like 5 of each of these boards. I ordered 5 of the daughter boards for the medical tricorder, and then I ordered 5 prototypes of the hand scanner. And I was looking to create the front of the tricorder, but when I cut and pasted it, I realized that I forgot to connect the positive and the negative leads to both of the circuit chips, and that's kind of like super important, you know, because it's like the power, you know, in and out. And I went ahead and ordered them already, so I'm going to be getting like 5 of each that are both completely defective and won't work at all. So anyway, I went back and I fixed it, and I just need to reorder the new ones, but I just wasted, like, you know, not a lot of money, but you know, when you're a little poor, and you pay a little bit of money for this stuff, and it, you know, the hobby ends up adding up if you make these mistakes. And we're talking like, you know, not that expensive of a mistake, but you know, a little bit of a mistake that's going to cost a little bit, you know, because they're going through the whole process, and you know, it's a little tragic, but you live and you learn. That's why always, just like breadboarding your circuit boards, your circuits, you always want to double and triple check and quadruple check your design before you send it out, right? That was my bad. I was getting all excited. I designed it all up, and I was like, yeah, I've got it. Let's get it. You know, I'd ordered it. But, yeah, because it'll take like a couple weeks to get here. You know, I just wanted to make it happen a little quicker, you know, because I have to wait 2 weeks. So I'm like, well, you know how it goes. Anyway, moving on. So here's the hand scanner circuit board. And we're talking like each one of these, like look how big the chips are. I mean, these chips are tiny. So, I mean, this is going to be a really small chip. And luckily, I double checked it all this time, and the whole thing should be working great. and I'm super stoked. And that's the hand scanner driver board. Oh, also the switch that I put on it, oh man, that was tricky to find. I had to like scrounge and scrounge and scrounge, but I found the perfect switch for it. So I'm totally stoked about seeing that. So I have to design the hand scanner, and I mean, we're talking like that thing has to be like that big, like smaller than the size of a dime. And then somehow I have to figure out how to solder stuff onto it. I mean, this is gonna be crazy. All right, here's what I came up with. All right, this thing, I mean, it's gonna be tiny, like really tiny. Like, we're talking like, these are inches, so like less than a half an inch for this whole thing. I mean, that's crazy. And somehow I'm gonna have to be able to solder 8 LEDs onto this thing, nine LEDs. There's gonna be the red one in the middle, and then there's gonna be the others. And I couldn't figure out a way to get any sort of like wire leads in there, because I mean, we're talking, this is gonna be super tiny. So I'm just gonna hook up the wires to the leads of these right here, right? I'm just gonna hook like positive, and then I think there's like 2 negative hookups, probably like 1 negative for the red and then a negative for all the greens. And there's gonna be like a green, and these greens are gonna light up, and then those greens, and they're gonna sequence, so it's gonna look like it's spinning around. It's gonna be pretty cool. And then somehow I need to solder some wires onto these, so that's gonna be super fun for sure. Okay, so I'm in JLC PCB, and I finally put in the order here. As you can see, it's like pretty cheap. See, 5 of them are $2. So, you know, do the math. That's like probably like what, 30 something cents, 35 cents a board. I also got the Science Tricorder version of the same one, and this took a lot to get, and I have to remask this stuff because I don't really like to wait, and I had a little bit of a paint slip issue, so I had to repaint it, sand it down, redo it. So it's gonna look really nice when I'm done with it. This is the paint that I'm using to paint these. I know that you can't really tell because I have it like way oversprayed with other paint, but it's stone gray or Stolium. After the stone gray, I just kind of dusted it with this metallic chrome, and that worked really well to get that kind of computer look. There's a piece of dust right there, you know, because you kind of want it to look like a laptop kind of shine to it. So I think that's kind of neat. What do you think? Well, I'm learning lots of lessons on this one for sure. You know, I was in the Navy for like 5 years doing electric stuff, and I learned a lot there too. And I admit that I knew quite a bit of what they were talking about, but some of it I was like, look, I have no idea. Like logic circuits, I mean, I guess I sort of understand the concept of it, but I just kind of was terrible at that particular subject. Like, for some reason, it just never really got into my head. So now here we are dealing with the same concept, but it's electronics this time, right? With this tricorder project, we just want to get some blinking lights and some sound going on. You know, how hard can that be? How hard can that be, right? Turns out that it's a little bit taxing on the brain, but it's not that bad. You just have to just sit through it and I had several people on YouTube going through the circuit and just explaining what everything does. And so, you know, what each resistor does, and then you get into the whole realm of creating a circuit board and mounted circuits and doing the, what is it called, the SMDs, the surface mount stuff, you know, and that gets extremely complex. Like I was trying really hard to understand exactly what all the numbers were. Like for instance, 0805, what does that mean, for instance? That's the size of each one of the components, and it turns out you can go even smaller and even smaller and smaller. And so I think that I finally figured all this stuff out, but I had to learn a lot doing all this stuff. And so now it's time to move forward and continue working on this tricorder. Here's the array that I'm going to use for the back of this medical tricorder. I have the 5 different wires coming out. One's the ground, because I have it, 2 of them are wired in series, and then they're going to go out, and you have the green coming in. The green is the ground for all of them, and then each one of these is a separate positive for the 2 LEDs in here, and there's 8 total, but only 2 of them are going to be lit at a time, and they're going to sequence in 4. And so that's how that's going to work, and it's going to look pretty amazing. That was like the first major electronics hump that I got through, and I probably could have soldered it a little bit better, but I think it's going to work great for its purpose. What do you think? Look what I found. I know the cat played with it a little bit here, but check it out. What do you think that could be used for? This is an LED. See, it's pretty cool because it has basically 2 LEDs in it, and they're 2 square LEDs put together to make a fat rectangle. Check this out. This is the best part right here. All right, you ready? You ready for it? Ready for it? Check it out. Perfect. Perfect size. Check it out. So now I just need to figure out a way to put that into a printed circuit board so I can have these now sequence. And then remember that 3 sequence LEDs that I had set up? That's going to go right in that slot right there. Isn't that pretty cool? And then those are going to be yellow. They're going to be always lit up. It's going to be red. And then of course those, I still need to design a better circuit board for those so I can have the square LEDs in them. It looks great on camera. Maybe a little bit dim in person, but dang, look at that. Nice. Check out these prices. For 5 pieces of board, $2, right? The other one's $4. And then they put it together for me for, this one's $15.66, and this one is what, $19.59. Has the button on it. Yeah, it's gonna be pretty cool. So we'll order this again and we'll see how it goes, and we'll see what happens. I have the board made completely correct this time, so should be good. So yeah, I've been having a lot of fun here. I live in Juneau, Alaska, so there's not a lot to do here. Somebody asked me once, what is there to do in Juneau? And I said, well, we watch YouTube and we get projects. We do a lot of projects. I've been painting someone else's garage for a little bit, so that's fun. I also sell insurance, so good times. I get to hear all about the insurance stuff here. Anyway, Good seeing everybody. Like to hear from you all. If you want to comment below, I'm going to continue on this project, this tricorder project, and I'm going to have to put it up on the shelf for now until we get those boards. Then we'll see some light on it. It's going to be super exciting. So we'll see you guys in a couple weeks when we get the boards. Alrighty, take care.